Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
He is working, so he did his PhD in California, in San Diego, with Gene Sudik, and he's now in Madrid working on distributed privacy and security and some of the cloud computing.
So welcome everyone, thanks for having me. So this is a joint work with Emiliano De Cristofaro, my former flatmate, actually too much time spent together. First of all, why we're working on PEPSI? As any talk, we start with motivation, where there are pretty much two. First one is the algorithm to have an appealing name in your paper. So you pick a cool acronym, and then you make up the words of the title, and you try to motivate your choice. If you're not happy, you go to one. Another motivation is that there are lots of food in cryptography, actually, but there were no drinks. So that's why we came up with PEPSI. Apart from jokes, these participatory sensing things, it's a very hot topic, in my opinion. So it's a very fast-growing computing paradigm that deals with the seamless collection of data from a large number of devices. And those devices are user-carried devices. Those are your mobile phones. Okay? It's about harvesting dynamic information of environmental trends. Whether they're this interesting or not, there are people from other departments that are looking at it. But there is a big potential with this kind of, for new applications and for new business models. There are over 5 billion phone users as of now. That was BBC report 2010. And those devices are always on, always carried, and always connected. And on top of that, they have a number of sensors embedded in it. You get accelerometers, you might get thermometers, and the basic idea is that people might be actually more interesting than modes. The information they carry and the information that they collect from their environment, from their everyday life, might be actually more interesting than a dull gadget as a sensor that sits in the ground or in some piece of concrete out there. There are lots of projects going on, and there are lots of, yes?
So basically, when you say participatory sensing, there's other paradigm called continuous sensing systems, right? So where you have this mobile phone and data gets collected continuously from all the sensors in a phone. And when you say participatory sensing, does user have to explicitly do something on it, or is it running in the background collecting? You're basically including both the kind of paradigms, or only one side?
That's a good point. Actually, there are two different flavors of this participatory sensing. One that is seamless to the users, transparent to the users, that is this continuing sensing, that basically is the phone that is continuously gathering data about the environment. And there are other flavors, other fashions of this paradigm where actually users have to do something, right? For example, there is a project that is good at this webpage, Sensor Planet, that is sharing consumer pricing in offline market. Okay, so here basically users have to do something to provide information to the system. For example, I can provide the price of the goods of where I go shopping. So if somebody else is looking for the same goods that I had looked for, he can just take a picture of the barcode and send this picture to along with its location to the system, and the system will tell him if there are other shops in the area around, in the surrounding area, that sell the same good at a cheaper price. Okay, so this is not seamless. This is something where the user has actually to participate, but we also target the seamless collection of data. But in both cases, there is human action involved, or at least resources of the computing device, right? So you have to spend some battery and some computational resources of your mobile phone or any sensing device that you carry with you. So the real question is whether you want to do it or not. Okay, so that's the real gist of the problem. What do you get back from that, right? Okay, so the number of projects is pretty big and it's growing. So we have a web page where we have trying to collect all these projects, but the fact that the topic is hot is supported by the people who are working on it. So we have Stanford, we have Berkeley, we have UCLA, we have Intel, we have Nokia. So everybody is looking at these new applications because there's a huge potential there. Okay. So the first question is, well, is this actually a new computing paradigm, or is it just WSN? Well, we have some differences. First of all, of course, WSNs are very the sensors that we see in regular WSN are very resource-constrained devices. Here is not the case, because here we have very fancy smartphones with lots of battery. The battery can be recharged. Computing power is not a problem. Memory might not be a problem. But the real difference is the one here at the bottom. So far in WSN, the owner and the network manager of the network was actually the one querying the sensors. So for example, the National Traffic Authority embedding sensors in the concrete of the streets and querying for the status of the concrete. Okay, so there's no real privacy issue here. In participatory sensing, users are providing data that is gathered by their mobile phone about their surrounding to other people. So here there are actually different entities that coexist and might not trust each other. So here we do have a privacy problem. So this is the big picture. That's your mobile phone, and this is the crowd that might be interested in your data. The peculiarity of this system is that the data producer and the data consumers have no mutual knowledge. They don't know each other. They have never met. So we actually do need somebody in the middle, a service provider or a broker, as you might like. So this means that data producers will produce data without knowing whether and who will eventually look for this data. So I can send from my mobile phone, I can send measurements of the temperature of the area around me, but I have no idea if anybody will ever be interested in that. And on the other side, querier might ask for one particular type of data, but don't know if there is anybody who ever contributed this data, or so if the query will be satisfied or not, and who this anybody will be. Okay. So that was pretty much what we said before. How can we have participatory sensing going live? So how can it go mainstream? Well, the first thing, users must be motivated to participate. And that's probably something we are not very good to tell, because it's about designing business model to incentivize users to provide their phone resources and participate to this game. One of the easiest things that we could say is discount the data plan. So the more I provide data with my smartphone, the less I'll pay when I make calls. Okay, that's probably the easiest way to go, but there are lots of people discussing on which is actually the economic models that would fit in this new computing paradigm. But what we're looking at is the privacy problem here. If users feel that their privacy is endangered, they will not agree to participate. And if we don't get a critical mass of users providing data to the system, participatory sensing just doesn't make sense. So this is really based on the fact that a large number of users will provide their phones to participate in the system. If this doesn't happen, participatory sensing makes no sense. And to make this happen, you want users to be guaranteed about a certain amount of privacy. It's a new computing paradigm, so it has not been there hasn't been lots of work on it. There have been lots of proposals. There are project applications, for example, the ones about the sharing prices in the offline market, and there's also lots of surveys discussing about security and privacy challenges in this model. The only work that we are actually aware of about privacy was at Mobisys 2008, and we were not very happy with it, so that's why we started looking at participatory sensing. what they do, first of all, they only work, the system only works with a Wi-Fi infrastructure, okay? So no matter your phone has a 3G, 4G connection, they assume a ubiquitous Wi-Fi infrastructure. That might not be the case, at least in my opinion, I don't see it coming. Why is this? Well, because they afford anonymity using standard IP MAC address recycling techniques. Okay, so they basically are anonymous towards the access point doing these kind of things. And on top of that, they use key anonymity through mixed networks to keep the privacy of the users sending out data to the system. And to have all this working, they have basically 3 independent and non-colluding anonymizing entities. That's a little bit too much from our point of view. So those are pretty much the limitations. Assuming a Wi-Fi infrastructure. This is the first point we were not happy with. So we want to go for 3G, 4G network also because the system will work only if, for example, with continuous sensing, only if the device is always able to provide data. And this is not the case if we are relying on a Wi-Fi infrastructure. So we really need to go to 3G, 4G broadband connections. And also the problem with mixed networks. Those are statistical methods that only achieve k anonymity. And in some scenarios, this might not be an option. For example, to achieve k anonymity, you might need to wait for reports for enough reports to come in before you can send out stuff. So you basically, if you need reports in real time, that might not be an option. Anyhow, they are looking at statistical methods to achieve privacy. So we want to look at provable security. That's where we are aiming at. So that was the contribution of this first work about participatory sensing. So we're looking at the cryptographic treatment of participatory sensing and define the privacy of both the data consumers, that are users querying for data, so querying for which is the temperature in Cambridge today, and the data providing data, so mobile phones sending out the readings of the temperatures in their area today. And we also provide an initial instantiation based on IBE. Okay, so which are the involved parties in our architecture? So first of all, you got the sensors that are installed on smartphones and emit data reports. That might be with or without the involvement, the active involvement of the user. Doesn't really matter. And then we have carriers. Okay, so those are people carrying the smartphones. Sensors might be embedded in vehicles. Can be even carried by animals, but I'm not sure if cows are interested in their privacy. But I mean, anything can be. Together, for us, they are mobile nodes. Okay, so for example, Markle phones, it's a mobile node. Okay. On the other side, we have queries. Those are user or application that subscribe to specific information. The temperature in Cambridge. So every day I get to know, I would like to get to know which is the temperature in Cambridge, and I want it to pop up on my desktop. On top of that, you have a network operator that basically manages and provides access to the network. So that's, for example, T-Mobile. And you have a service provider that is intermediary, the broker between users providing data and the queryers asking for data. Okay? As of now, this is the required parties for a non-private participatory sensing application. Okay? So if you go for participatory sensing and you forget about privacy, that's at least what you need. On top of that, when it comes to security, we also have a registration authority that would be a phone manufacturer or any other stakeholder in the system that basically handles the registration of participatory parties. So this is the only other entity that we introduce in the system. And this is pretty much the architecture. Okay? So here we have data producers that are the mobile nodes. They first register to the registration authority. So here basically they download the software to participate into the application. On the other side of the system, you have queryers as well. They need to register. They need somehow to get authorized to receive one particular type of measurements. For example, once again, temperature in Cambridge. And if I want that, I need to register to the registration authority. Once I'm registered to the registration authority, I get a token that I provide to the service provider. This is the broker, okay? This is the intermediate between data consumers and data users. So registered mobile nodes emit their reports through the network operator to the service provider. The service provider does the math, so it checks which reports are of interest to which queries and forward those reports to the queries. Okay? So this is pretty much it. So if I'm there and I'm looking for temperature in Cambridge, I'm only going to get reports that are tagged with temperature and Cambridge. Privacy requirements. First of all, we want the solution to be sound. We are not looking at false positives, false negatives. So there are lots of there are lots of work about outsources database, privacy in outsources database that achieve privacy, providing a set of answers that include the answers that actually satisfy the query, and this is to protect privacy. We don't not want to go there. We just want a solution that provides me the right answers. I don't want false positive or false negatives. I also want query privacy, so I want to protect my interest. I don't want anybody to know on what data I'm querying. I don't want anybody to know that I'm interested in the temperature here. I don't want anybody to know that I'm interested in the price of some drugs that I'm looking for. Okay. On the other side, you also want node privacy. So whenever I send out a report from my mobile nodes, I only want authorized queries that are looking for that data to know what is that data about, and nothing else. Okay. So which is the intuition? Sorry. Of course, we need to hide reports and queries. If we want to protect privacy of both data producers and data consumers, we need to hide reports and queries. So they need to be encrypted, and somehow the service provider needs to do the matching blindly. So again, if you are providing data about temperature in Cambridge and I'm looking for the same data, so with data with the same tag, this matching has to be done blindly by the service provider. The naive solution is, of course, using pairwise key between queries and mobile nodes or public key encryption, but both solutions do not work in this case because, as I said, one of the particular features of this system is that users, data consumers and data producers do not have mutual knowledge, so they don't know of each other. There might be nobody interested in the data that I provide, or there might be nobody that is actually providing data that I'm interested in. So here's the main intuitions. We can use IB-based cryptography. So probably we're going to use the Bonnet-Franklin instantiation. We treat query identifiers like identities of an IB scheme. Okay, so temperature in Madrid is actually the identifier, is actually an identity in the IBD scheme. So we encrypt our reports under the identity, and once this is done, we only need to find a way to provide authorized queries with the corresponding decryption key. Okay, so here is really the baseline of the paper, using query identifiers as identity and providing the corresponding decryption key to authorized users. So how it works? Sure.
So this identity-based encryption, isn't it actually an attribute-based encryption scheme?
Right.
I mean,
Yeah.
because that's what you do, right? You have attributes and you encrypt all
Right.
that.
Pretty much would be the same, yeah. So this is done offline. So the setup is executed by the registration authority, and it's basically the setup of an IB scheme. There is a bilinear map, and there are a bunch of hash functions. And then we go online. Okay, so here are the involved parties: the registration authority, mobile nodes providing data, queries asking for data, and service provider doing the matching in the middle. So those are the public parameters, and those are secrets, S and Z. So at registration time, so the mobile nodes needs to be authorized to provide information to the system, to provide data reports to the system. So at registration time, the mobile node just gets Z. So here you can do it in a fancier way. So you can anonymize the mobile nodes, or you might do something not to have the registration authority learning for which kind of reports the mobile nodes wants to participate. But it really depends then on the business model, because probably if that guy is going to get discounts for what for the data he's providing to the system, maybe you really want to know who that is and things like that. Also, the querier need to register. They need to register to get one particular upload to the service provider queries of one particular type. So this is the ID of the query, for example, temperature in Cambridge. What they get is basically a signature on the ID, and actually you can do this blindly, so the registration authority doesn't learn which is the query that the querier is interested in. Once this is done, now we really go online, okay? So you have Z on one side, and you have the signature on one particular type of query on this other side. So now the query has to offload the running query to the service provider. This running query is called a continuous query, as we want to call it. It's called like that because you just send it out once, and you get back data anytime there is interesting data, there is data that satisfies your query. So it's not like in a database where you just issue the query once and you get back once the results. Here you offload the query stands out there, and whenever there is interesting data at the service provider, this data gets back to you. So this running query is basically this tag that it's a hash of a bilinear pairing, of a bilinear map with the R that is one public parameter, where the Z is embedded, the Z is on the other side, and a signature here that is the signature of the registration authority given to the querier about that particular kind of query, temperature in Cambridge. So now the service provider has T. Let's look at what happens at the mobile nodes. Now the mobile nodes needs to provide report, okay? So what it will provide is a pair TCT, where basically CT is the encryption under, this is a, let's say a symmetric encryption algorithm, AES for example, under key K of the data report, okay? And this key is derived somehow by the nature of the query. So here is temperature in Cambridge, and here is 23, for example, okay? And the tag that it will be used to identify this kind of data, it's actually pretty much the same thing here, but with a different hash functions. So you will provide this pair, T and CT, where this is a header, where there is an encrypted tag, and this is the payload, and we'll give it back to the service provider. The service provider only needs to do matching between the tags sent by the mobile nodes and the tag offloaded by the querier. If they match, the pair is forwarded back to the querier, and the querier just needs to compute the same key. He can do that because he has a signature on the same ID that defines the nature of the data item, and once he gets the key, he can do the decryption using AES again. Okay? So that's how it works and why it is correct. Privacy. Okay, so two things, node privacy and query privacy. About node privacy, only authorized queryers that possess a valid signature obtain information about this pair. They can actually decrypt that pair. Okay, in the paper there is an adversarial game, and it's based on the CPA security of the Bonnet-Franklin IB scheme. And pretty much the query privacy works the same way. That is, no one in this paper, in the paper actually there is, except the array, so the array is actually allowed to learn information about query interests, that is the ID that is sent from the querier to the registration authority during the registration, but you can actually do it blindly, so you have nobody to learn what you are querying the system for. And again, it's all reduced to the CPA security IB. Since we are looking at mobile phones, we also took a little bit a look at performance evaluations. So we implemented the operations that are supposed to be carried out on the mobile phones on some Nokia N900. Those are the specifics about CPU and RAM. And actually, the only thing that mobile nodes need to do, so the overhead of the privacy protecting layer is the production of TCT, and that takes really little time. It's 93 ms on average. So we are not taking into account the energy required to sense the environment, because this is actually what the device should do anyway in a non-private participatory sensing solution. And actually, there are very little or no overhead at all at the other parties, because the service provider only needs to match hashed values. Okay, so there are tags that are hashes of something, and if they match, the service provider has to do the forwarding. And this is exactly what the service provider has to do in a non-private participatory sensing solution. And there's a negligible overhead for queries, because they only have to perform AES or any symmetric key decryption algorithm. So what we're looking here is something that doesn't really cost that much and adds some privacy to the system. Few open problems, of course. Well, the query privacy with respect to the registration authority, that's already set. So you can use blind IBE not to have the registration authority learning what you're querying for in the system. So if you're looking for particular drugs, we don't want anybody, not even the registration authority, to know that. You want to have fine-grade authorizations. So for example, you can have the temperature in Cambridge only if you're allowed to query for the temperature in Cambridgeshire in the UK. So that's something that you can do using hierarchical or attribute-based IBE. And then this is probably the most challenging part. What if you want to work on aggregates? You want to get the average temperature, other functions, some, mean, but you also might need to get predicates. For example, I do want the average temperature today in Cambridge, but only if it's above 20 degrees. And this is probably where we need to go, because if it's true that there are so many people, if these things strikes out, and there are so many people providing measurements, you don't want all the measurements on your phone. They're going to exhaust your battery. So you really want the service provider to do the math and gets to you only the relevant information. You might not really want all the data that actually the system is producing. And of course, future work is going to be to have some paper that is called COKE. We are looking on the acronym. So this is pretty much it. There are more information at this website. So thanks everyone, and I'll be happy to answer questions if you guys want. Mm-hmm.
So is the assumption that the registration authority and the service provider will never collude?
Right.
Right?
Yes.
Because otherwise the service provider would be able to get access to the signatures,
Right.
construct tags, and
Correct.
then be able to
That's
find
correct.
matching, right?
That's correct. Yes, the registration authority is trusted. Here we are looking at a scenario where it's the service provider that is not trusted.
Yeah, yeah. And I think this is inevitable, right? Because
Yes.
otherwise, just from the routing, you'd be able to infer that
Right.
information.
You have to put trust somewhere. Yes.
In terms of the business model, do you actually see that there is going to be a configuration where these two entities are going to be separate? Because my understanding is that a company would launch a service like this if they actually have both the registration authority and the service.
Yeah, that's a very good point actually.
And another thing, perhaps a bit related, I have a feeling that participatory sensing is happening in a way, but mostly by offering a different service and having the data as a byproduct. For example, Foursquare is giving a different service to people, but the company collects information that could be queried to extract other things. Same thing with mobile Flickr applications. I mean, they're offering a different service. Now, the thing is that, don't you have a feeling that privacy is actually going to be related mostly to the service that is given to the user and not the querying of the data? So if we take Flickr, for example, you can upload photographs, and the privacy is mostly related to the fact that somebody holds your photographs. Now, Flickr can also allow other people to query their database, and you can find information, photos from a particular location. So in a way, it's a participatory sensing service, but that's a byproduct. So I'm just wondering what's your kind of sense?
Yeah, I agree with what you say. It might be difficult to have some parties that is trusted and that is not somehow related to the service provider, because actually now the models that are out there have everything embedded in one single entity. But it seems that there would be, as we said, it's inevitable, there would be no solution if we go for that model.
Mhm.
Can you say a bit more about how to balance between producers and consumers? It seems that if there are relatively few producers and everyone is interested in the same or similar queries, then it should be very hard not to leak the full information about what has been uploaded.
I'm sorry, I'm not sure I got your question.
So if there is like 2 people who are reporting temperature in Cambridge and the rest of the world is querying about the temperature in Cambridge, then
That's true.
all the information will be extracted. So, and as far as I can see, there is no way to automatically balance or to check that there is not too much information being extracted after being authorized, especially if you blind the request to the trusted third party, then you don't know how much data is being extracted from one particular type.
Right. I mean, if I got your question, you are going towards pretty much this k-anonymity system.
I don't like k-anonymity, but I'm wondering what...
Right. The thing is, if you don't get a critical mass...
If it's not centrally managed, then there will be imbalance between how many suppliers and how many consumers of information there is, and then it's
Definitely,
very hard to have a guarantee a priori.
Yeah, it's actually one of the key points is having users participating. If users if you don't have enough a critical mass of users participating, the whole system doesn't make sense actually.